when you can factoring is a technique for solving any equation. And this one can be factored. Now, it's actually kind of interesting in the theory of mathematics. It's not, there are many fifth-degree equations which cannot be solved. In fact, almost all of them cannot be solved by some kind of quadratic formula type of technique or factoring technique. But there are always exceptions to those rules. And of course, here is one. So let's look at this. And we notice that we can factor an x out immediately. So I'll factor x out. That leaves x to the fourth minus 13x squared plus 36. And then it turns out we can factor this. Now the variable we're going to factor with is x squared, because I have an x squared term and x squared squared term. So this is a quadratic form in the fourth degree. So, and it turns out it's going to factor as x squared minus 4 and x squared minus 9. Well, you can see that I rigged this problem because these also factor into difference of squares. So I get these difference of squares factor into conjugates. So I have x times x minus 2, x plus 2. So this factors here. And this factors as x minus 3, x plus 3. So we end up with actually 5 answers. If you set x equal to 0, let me write those out. X is 0, x minus 2 equals to 0, x plus 2 equals to 0, x minus 3 equals to 0, x plus 3 equals to 0. If we set all those equal to 0, because the zero product property works on even something this large, if you're multiplying 5 numbers together and get 0, then at least one of these has to be 0. So what could it be? Well, x is 0. It could be 2 or negative 2. Or it could be 3 or negative 3. So this problem had 5 answers to it. And it's not a coincidence that it had 5 answers, because it was a fifth degree polynomial. All right, so you generally get as many answers as the degree of the polynomial when you're working with polynomial equations. It is impossible to get more than 5 answers, I can tell you that. It is possible to get some duplicates, so you might end up counting fewer than 5 if you have some that kind of repeat each other. All right, now I just want to, before I go on to another problem, I want to point out one little feature here you want to avoid. So this would be a wrong thing to do. And you always got to be careful when you divide by a variable. So let me put wrong up here. Okay. Because it may look tempting to divide this equation by x. So if I divide every piece by x, then we'll get x to the fourth minus 13x squared plus 36 equals to 0. And then when you go to solve this equation, you'll get 4 answers, but not this answer. In other words, when you divide by x, you lose one of the answers. So there's the moral of the story there is when you're solving equations, don't divide by a variable. All right. Now there's exceptions to that rule, but generally speaking, it's something you want to be very wary of, because when you divide by a variable, usually you eliminate a possible answer. All right. So, okay, I'm going to go on to one more example. Show you a technique called factoring by grouping. Algebra textbooks love to do factoring by grouping, so it's traditional. I'm going to throw one of these in here. I would think in real life this would be almost never ever seen. But anyway, it's good math. It really is good math. So let's solve this problem. Solve 4x to the third power minus 6x squared minus 6x plus 9 equals to 0. And we have 4 terms. Now this method of factoring by grouping only works when you have an even number of terms, like 4 or 6 or 8 terms. And normally being a third degree polynomial would be just about impossible to factor this. Or you might need some techniques that we study in a later chapter. But here, I sense because I made up the problem, but I would sense that we might be able to do grouping because there are 4 terms. And also, when I look at these ratios, 4 to 6, 6 is 1.5 times 4, and 9 is 1.5 times 6. And so there's sort of a common ratio here. Anyway, you'll see that unfold. What I'm going to do is separate this into 2 binomials. And you got to be careful because this is a very common place for students to screw up. You know, students just want to slap parentheses around these. But if you put parentheses over here, there's still a minus sign outside. So let's make that a plus. And then inside it's minus 6x plus 9. All right. So if you were to put a negative here, you could keep 6x instead of negative, but you would have to change this sign. You'd have to be pretty alert to catch that. So be very careful with this first step in factoring by grouping when you encounter these, because people will easily mess up negative signs and then it just turns into a disaster. All right, now what good did that do? I'm going to factor x squared out here. In fact, I can factor out 2x squared. And so 2x squared, and that leaves